All right. So we're almost completely finished with this circle section. We talked about the center radius form. We've talked about general form. We went between the two forms. Yesterday we talked about graphing a line on the same coordinate plane as the circle and determining whether there were solutions. We had some that had two solutions. We had one that had one solution. Then we had some that had imaginary solutions because the line never actually touched the circle. Today we're going to go on and talk about semicircles. So, there we go. So that's at the bottom of page 216. So consider the graph, or consider the equation of the circle given in center radius form there. Solve the equation for y in terms of x. You should get two different equations. So let's just start with the first part. They just want you to take that original equation that we've already used, it's in center radius form, and let's plot that on the graph. So the center should be -3, +2. Still froze. There we go. Okay, so -3, 2. The radius needs to be what? 3, thank you. And that's our circle. The center was -3, 2, and the radius was 3. We should be okay with that by now. We've gone over that both days so far. Now the second part, they want us to solve for y. So in the middle we're going to put our original equation, x plus 3 squared plus y minus 2 squared equals 9. And we want to get that y by itself. So what we're going to do first is we're going to subtract over this term over here. So we're going to have y minus 2 squared equals 9 minus x plus 3 squared. We just subtract that whole term over. Now what do you think I need to do to both sides? Square root of both sides. So if I do that, that gets rid of the square on this side. So I'm left with y minus 2. And on the other side, I don't just have the square root of all of this. What else do I need to put on this side? I'm missing something. Think you have?
Plus or minus.
Yeah, the plus or minus. We're really close. We have one step left. So we need the y by itself, so we have to add 2 to both sides. So I would get y equals 2 plus or minus the square root of 9 minus x plus 3 squared. Yes? Sorry, what are you talking about? The square root is over everything. We have the minus sign there, so you can't really split it up. If they were multiplied, you could split it up. If it was 9 times that, you could take the square root of both of them. Okay, so I actually want you to write these separately. So we're going to have y equals 2 plus the square root of 9 minus x plus 3 squared. And y equals 2 minus square root. Okay. And then if we actually think about our circle, so we haven't actually changed anything, but over here they want us to graph the two equations you got. And this is using 2 different colors. You can just label them if you'd like to, or if you do have any colored pens, or if you want to use a pen for one and a marker for another.
Interruption. I need the following students to report to room 86.
Michaela Nicholas, Michaela Bowersock, Eli Lindsay, Brooke Miller, Jack Mason, Sarah DeVore, and Sam Lynn. That's Michaela Nicholas, Michaela Bowersock, Eli Lindsay, Brooke Miller, Jack Mason, Sarah DeVore, and Sam Lynn to report to room 86.
So we still have the same center. That's at the -3, +2. Because we're representing this circle over here, but we're representing this original one with two different equations. So the 2 plus, that's going to be the positive part of the circle. So 1, 2, 3, we still have the same radius. But that equation represents the top of the circle, so that's a semicircle. And the 2 minus part will represent the bottom. That marker's not drawing very well. And that is the bottom portion of the circle. So the 2 semicircles make up 1 circle. So recognize how this circle's made up, because we're going to do something similar in the next example, but it's going to look a little different. So we solved for y. We got 2 answers. The first answer represents the semicircle on the top. The second answer represents the semicircle on the bottom. Again, so right here are both answers. If you would go work backwards, you would get the original circle equation. Any questions? Alright, let's go to the next one. On the next one, they tell you to consider the equation there given in circle or center radius form. They want you to solve for x in terms of y this time. So let's start by drawing the circle. So the center is at -3, 2 again. Radius of 3. So we have the same circle. Again, the center, -3, 2. Radius is 3. Now we're going to go through the same process with the original one, except we're solving for x this time. So if you want to work ahead and just check as you go, you can, or if you want to follow along on the board as I go. Solving for x, so I'm going to leave the x plus 3 squared, subtract over the y minus 2 squared, square root both sides. After I square rooted both sides, I subtracted over 3, and then I just wrote out both of my answers, the plus version and the minus version. So once you get to this point where you have your 2 answers, again, they want you to graph the 2 equations. So we have the same center, -3, 2. But for the x value, it's going to look a little different than it did for the y. So we still have the same radius. But when we're talking about the x, it's going to be this portion over here. That's for the plus answer. It's the right portion. And for the minus portion, it is on the left. So we have two semicircles again that make up the whole circle, but we solved for two equations in terms of x this time. So if you were to plug values into your x and y, these are the two lines that you would get, and you would create these two semicircles to create one circle. And that's basically all we're going to cover with the semicircles. Just knowing that there's two equations that actually can make up the entire circle. And just look at the difference from the y's to the x's. So when you have x's, it's the left and right side. When you have the y's, it's the top and the bottom. Okay? Any questions? Alright, so we are going to go ahead to the next section and start talking about ellipses. So page 223. Alright, so ellipses. Looks very similar to a circle, except it looks a little elongated. So it's not exactly circular. It's not a perfect circle. So, pictured to the right is a graph of an ellipse. Before we begin to study the relationship between the equation and the graph of an ellipse, we need to first have a vocabulary lesson. So below you will find statements with words underlined. Based on the graph, see if you can come up with a definition of each underlined term. Obviously the center is the point 1, comma negative 3, so that's given right there. It's going to be the center of the ellipse. So now let's go through each of the definitions. So number 1 says the points 1, comma 2, which is this point at the very tippy top, and 1, comma negative 8, and one at the very, very bottom, are the vertices of the ellipse. So we need to try to come up with a definition or something to describe those points. In terms of the picture, what do you notice about them? Maybe it's not necessarily a definition, but what do you notice about those 2 points compared to everything else? Any ideas? Thoughts? Go ahead. Okay, in this one, they are vertical. They're not necessarily going to be in every example, but this one they are, so that's good. A good thought. Any other guesses? Okay, we're getting closer. It is true, they're on the outside, but what about them? What do you notice about these 2 points in particular? Exactly, they're the furthest points from the center. There's no other point that is further away than this. So the vertices are the points on the ellipse that are the greatest distance from the center. Very good. The vertices are the points on the ellipse that are the greatest distance from the center. There's no point on the ellipse that is further away from the center than those two. Alright, let's look at number 2. The points -1, -3, so right here, and 3, -3, right here, are the co-vertices of the ellipse. So what do you notice about these two? They're the points that are closest or the least distance from the center, yeah, so the co-vertices are the points on the ellipse that are the closest to the center. Alright, so once you get that down, we have two that are similar to each other, 3 and 4. So number 3, the length of the major axis is 10. So how do you think we can describe that, Rebecca? Yeah, the distance between the vertices, exactly. The distance between the vertices. Very good. The length of the minor axis is 4. So this one would have to be the distance between the co-vertices. So if you take a look up at your graph, go from the top vertice to the bottom one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The major axis is 10, and the minor axis, 1, 2, 3, 4. So we don't actually have a radius, it's not a perfect circle. That's why we have to talk about the major and minor axis there. Because we're going to have two different values. There's no constant radius. Bless you. Alright, as we move along here, there are two other points labeled on the graph. 1, 1.583. So it's that one that's really close to the top. And then we have 1, -7.583, so really close to the bottom. Not quite there, not quite to the top, but close. These 2 points are called the foci of the ellipse. From this information, it is a bit far-fetched to expect you to be able to define what these are, so let us do a little investigation. So measure the distance from the top focus to one of the co-vertices. This distance should be the same as what other distance? So measure the distance from the top focus to one of the other co-vertices. So they're saying from here to here, that should be the same as what other distance? Any ideas? That's true. I think I understand what you're saying. From where to where? You're saying from here to here is the same as from this one to where?
Sorry, to the other co-vertice.
To this one? Okay, that is true. Yes, that is true. So the distance from here to this dot right here is the same as what else on this ellipse, do you think? Go ahead. You're really close. not the foci to the center, which is the focus, so not from the focus to the center. From the vertice to the center. So the distance from here to the focus is the same from the vertice to the center. Okay? So we're going to go ahead and write that down below. The distance from a focus to a co-vertex is the same as the distance from the center to a vertex. So it says now, construct a right triangle so that one leg of the triangle is the distance from the center to a focus, the other leg is the distance from the center to a co-vertex, and the hypotenuse is the distance from the center to a vertex. Based on the picture you have just drawn, what relationship must be true about the right triangle based on the Pythagorean theorem? So back up here, they want us to go from the center to a focus. So that's the dot almost at the top. The other leg is the distance from the center to a co-vertex. Co-vertex is the closest points. So the hypotenuse would be right here. But we said that this distance is the same as what distance? The hypotenuse of this triangle would be the same distance as what again? It's equivalent to what distance? So we're going to write out the Pythagorean theorem in words. So let's think about it at the bottom. So it says, based on the Pythagorean theorem, so distance from center to co-vertex, that's a one quantity squared. So we're thinking about the Pythagorean theorem. Distance from center to co-vertex, that's one of our sides, one of our legs, plus distance from center to focus and this is squared. That would be equal to what distance? That's what I'm trying to get at. We know that it's the distance of the hypotenuse of that triangle we just drew, but it's also equal to what? And we did mention this a few minutes ago. Yeah, distance from the center to the vertex. And that is squared. So using the Pythagorean theorem, if you know the distance from the center to the co-vertex, that's the closest points, and if you know the distance from the center to the vertex, the furthest away points, you could use the Pythagorean theorem to find what they called the focus, that point that's almost at the top and almost at the bottom. You'd be able to find that point called the focus. Okay to move on? Alright, so let's actually get a look at an equation of ellipse and how to actually understand their equation. So kind of like what we did with the circle, we're going to explore it and try to figure out what means what in this equation. So study the equations and the graphs of the ellipses below, and see if you can determine the connection between them. So go ahead and look at the first one, what we're trying to look for. So we know terminology, we're looking for the center point. We're trying to determine the major axis, and we're trying to determine the minor axis. So that's the terminology for the ellipse. Those are the things we're trying to find out from the equation. So look at the equation now and see if you can figure out that information. Any ideas? Are we able to find the center? Do we see where that comes from? Kind of like the circle, negative 2, 3. It's the opposite, so negative 2, 3. That's our center. What about the major axis? Are you able to figure out how we can calculate the major axis? Okay, well let's start thinking about the major axis. From the center to the outside is how far? To the vertex. We know that's 4, but the whole major axis has to be what then? Okay, so we know the entire major axis has to be 8. But let's look at the y, because in terms of this problem, the major axis is going straight up and down like the y-axis. So if we look under the y, we see 16. Well, if you take the square root of 16, you get half, just like we did with the circle. When you have the radius, you take the square root to find the radius. So this is half of the major axis, the square root of 16. So if that's half of it, again, how big is the major axis? You have to add it twice, or multiply it by 2, you get 8. So knowing that, how do we find the minor axis? The square root of 4 would be what? It is 2, but that's what in terms of the picture? It's half of, what was that, Marie? Just half of what? The minor axis. It's half of the minor axis. So if 2 is half, well, the whole thing must be 4. What did we notice that this first equation is equal to? It's equal to what? 1. So let's take a look at the second graph there, and we would also want to try to make it look like the first one. So we don't see any fractions yet, and we see that it's equal to 100. So we actually want to try to make that equal to 1, so we have the same format of the equation before. So how could we make this one equal to 1? What can we do? Whatever we do, we would have to do to both sides, but what can we do? What can I do to 100 to get 1? Divide it by 100. So if I divide that by 100, I would get 1 over here. If I do 2 times x minus 3 squared and divide that by 100, that would simplify to what? I would get x minus 3 squared over what? Over, would you say 50 or 1? What'd you say? So if you have 2 divided by 100, the 2 would cancel out with the 100 to make it 1 over 50. Yep. Then on this side, the 4 and the 100 would cancel to give you what on the bottom? If you divide by 100, 4 divided by 100 is what? You'd get what in your denominator? 25. Very good. So now it looks like the same format. So we can try to find the center, the major axis, and the minor axis. So the center, we look at it like the circle. Well, it has to be the opposite, so 3, negative 1. So 3, negative 1, well, that is the center, just like in our picture. And let's look at the minor axis first. In this picture, the minor axis, so that's the smaller one, is actually the vertical one, the one that's up and down, because we see it's elongated this way this time. So the minor axis is the one straight up and down. So if we look up at our equation for the y up and down, we see 25 on the bottom. If we take the square root of 25, you get what? 5. But what do we have to do to get our minor axis? Rebecca? Okay, so the square root of 25, I get 5, and what do I have to do with that value? Yeah, because 5 is only half of it. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the minor is 10. And for the major, if we do the square root of 50, well, that's not exactly a square root that we know, but what is it close to? We know a square root that's really close to 50. Square root of 49. So the square root of 49 would be one side. Well, it would be close to it, which is about 7. So the whole thing has to be about what? About 14. So it's close to 14. It's not exactly 14 because it's the square root of 50, not 49, but it's close. Alright, so we're going to stop there so we don't really get into any new ideas with the little bit of time we have left. So we'll pick up there on Monday. We'll review these questions again so that we can answer the questions below, and then we'll move on from there, okay? So with any time remaining, if you want to work on homework or at least get a look at the homework for this section or finish up the circle homework, that's up to you, but you have a few minutes left.